You can cut it with a handsaw. Drop a block in a bucket of water and it floats. It weighs 1/5 of a standard concrete block. Thread steel rebar through its core, and you have a wall system that flexes under seismic load and returns to position. Not in theory. In documented post-earthquake engineering surveys. In structures that were still standing when everything around them was gone. Japan uses this material. Germany uses it. Britain uses it. Across seismically active regions on 4 continents, engineers have built with it for decades and watched it perform when the ground moved. After the 1995 Kobe earthquake, magnitude 6.9, approximately 6,400 people killed. Japanese engineers studied what collapsed and what did not. The results changed Japanese building code. Reinforced autoclaved aerated concrete, AAC, was integrated into the seismic design framework. Japan decided that what worked should be what people built. The Cascadia subduction zone runs offshore from Northern California to British Columbia. The United States Geological Survey has documented its capacity for a magnitude 9.0 event. Not a 7.0, a 9.0. The kind of ground motion that liquefies soil, collapses overpasses, and turns conventional residential construction into matchsticks. USGES estimates that when it ruptures, not if, when, it will be one of the most destructive seismic events in North American recorded history. The standard residential building code in Washington and Oregon is still wood frame. There is a material that survives what Cascadia will produce. There is documented evidence that it does. There is a country that changed its policy because of that evidence. And there is a fault offshore of the Pacific Northwest that is, at this moment, accumulating stress it will one day release. The question this video is actually about is not what the material is. The question is why the code has not caught up, and who benefits from the delay. Here is the first thing most people assume when they hear about a building material that outperforms wood frame in earthquakes. It must be banned, or unproven, or so expensive that only commercial construction can justify it. None of those things are true. Reinforced AAC has published ASTM standards, ICC evaluation reports, and a documented performance record across seismic zones in Europe, Japan, and Latin America. It costs more than dimensional lumber, but it is in the same range as insulated concrete forms already used in US. Residential construction. It is legal, evaluated, available, and builders in the Pacific Northwest are not defaulting to it. In the 1920s, a Swedish inventor named Johan Axel Eriksson developed autoclaved aerated concrete, a cement-based slurry with millions of tiny air pockets. Pressure cured in an autoclave, light enough to float, easy to cut with a handsaw, and when reinforced with correctly placed steel rebar, capable of resisting the lateral forces that collapse wood frame structures at the foundation line. Europe rebuilt with it after the Second World War. By the time Kobe happened, it was already a known quantity in Japanese construction. What Kobe provided was real-world test data no lab can replicate. A major seismic event, documented building by building. Wood frame and unreinforced masonry failed. Reinforced AAC did not. Japan updated its code. In 1994, the Northridge earthquake produced similar documentation. American engineers saw the same data. The divergence is not in the evidence. It is in what each country decided to do with it. And this is the part nobody mentions. Reinforced AAC for seismic applications requires engineer-stamped drawings, rebar placed to specification, and correctly detailed connections at foundation, bond beam, and every roof intersection. The performance record belongs to industrial-grade AAC, not the foam aircrete in DIY videos. That gap is structural. The version that survives earthquakes requires an engineer. That is not a disqualification. That is the specification. If you want to understand the full engineered pathway and why it matters for your insurance and your mortgage, subscribe and follow this channel. So why does the residential code in Washington and Oregon still default to wood frame, even in the seismic design categories covering the Pacific Northwest? The International Residential Code's prescriptive pathway, the simplified route most builders follow, lists wood frame as the default. Any alternative requires engineered design, separate evaluation, and additional cost. That pathway is where the market lives, and the IRC is developed through a consensus process in which the American Wood Council, representing the lumber industry, maintains a sustained code advocacy operation to protect wood frame's prescriptive role. That is not a conspiracy. It is what trade associations exist to do. The result? A family in a Cascadia risk zone can build on a prescriptive permit, using wood frame, without an engineer ever reviewing the seismic design. The system is not broken. It is working exactly as designed, for the people who designed it. A homeowner who wants to build with reinforced AAC today faces a process wood frame does not require: an engineer's stamp, plan review delays, an appraiser with no comparable sales, a bank with no underwriting category, an insurer whose models were built on wood frame loss histories. They do not need to ban the material. They only need to make it harder than the alternative at every step. Here is what you can do today. USGS and FEMA publish seismic hazard maps by location. Look yours up. If you are in SDCD or E and in Western Washington or Oregon, you likely are. Reinforced AAC is legal under an engineered design pathway. You need a structural engineer, experienced with reinforced masonry or AAC seismic design. Ask specifically. Request references. The pathway exists. If you want the checklist of questions to ask a structural engineer before building in a Cascadia risk zone, drop the word Cascadia in the comments. Now pull back. There is a fault that has ruptured before and will rupture again. There is a material with a documented seismic performance record, published standards, and legal pathways in the states most at risk. There is a country that looked at the same evidence and changed its code. And there are families building homes right now on prescriptive wood frame permits, in seismic zones, without an engineer reviewing their design, because that is what the code makes easy, and the market makes affordable. Subscribe and help us make this harder to ignore. The material already knows how to survive the big one. The only question left is whether the people who write the code will decide that the families in its path deserve the same chance.